Okay, Algebra 2 skills number 29, slant asymptotes. Again, we'll remind you that an asymptote is a line that a graph approaches more and more closely. It may cross it, it may not. Just depends on the situation. So for a slant asymptote specifically, you can read here, it says a slant asymptote only applies when the numerator degree is one more than the denominator degree. So if you're familiar with horizontal asymptotes, you know that if the numerator degree is larger than the denominator degree, then there is no horizontal asymptote. Well, if the numerator degree is exactly one more than the denominator degree, there would be actually a slant asymptote. Okay, so the way you find it is to divide, just create like a division problem or work it like a division problem using either long or synthetic division, depending on what you have. You do ignore the remainder because the remainder becomes less significant as you extend the graph. The quotient is a slant asymptote. So let's look at an example to illustrate that. Find the slant asymptote. So notice right away that our degree of the numerator is exactly one more. So the degree here is 2, the degree here is 1. So what I'm going to do is just treat this like a division problem. I'm just going to divide it. Because the dividend, this part here, is not of the form x plus or minus a number, I must use long division. So let's do that. Okay, so we just have it all worked out right here. This is the same problem just written in division form. So, where did all this come about? Well, if you know long division, then you can follow along here. If you don't know long division, what we did was take this first term, 2x squared, and divide it by this first term, 2x. 2x squared divided by 2x is x. We then took this x and we multiplied it times 2x to get 2x squared, and times 3 to get 3x. We then changed the signs. That's why this is in red. So that positive 2x squared become negative. That negative 3x, if you multiply it, became positive. We then added, that cancels. 9x and 3x becomes 12x. We drop the 6. And then we repeat that process. 12x divided by 2x is positive 6. 6 times 2x is 12x. Change the sign. 6 times negative 3 is negative 18. Change the sign. And you get a remainder of 12. But I didn't bother writing the remainder here because, as we said, the remainder is ignored due to the fact that with asymptotes you go a long distance on the graph, and over time that extra 12 doesn't mean very much. Okay, so this x plus 6 written in blue is our slant asymptote. Specifically, we write it as y equals x plus 6. Okay, so that quotient is our slant asymptote. So let's look at the graph. The red here is the graph of the original function, 2x squared plus 9x minus 6 divided by 2x minus 3. The blue is the graph y equals x plus 6. So this Desmos graph, you can see as red goes left, it's approaching that blue line more and more closely, the very definition of asymptote. And notice this is called a slant asymptote because it's an oblique line. It's neither vertical nor horizontal.